Hurricanes have long been a force of nature that both fascinates and terrifies us. These massive storms, capable of devastating entire regions, have been a part of our planet's climate system for millennia. But in recent years, scientists have observed a troubling trend. Hurricanes are becoming more powerful and destructive. Today, we'll be diving into the science behind these colossal weather events and exploring why they're regrowing stronger in our changing world. At their core, hurricanes are heat engines, drawing their immense power from warm ocean waters. As global temperatures rise due to climate change, the oceans are absorbing more heat. This increased warmth provides hurricanes with more fuel, allowing them to grow larger and more intense. The process begins when warm, moist air rises from the ocean's surface, creating an area of low pressure. As this air climbs higher into the atmosphere, it cools and condenses, forming clouds and releasing energy in the form of heat. This heat further warms the surrounding air, causing it to rise even faster and drawing in more warm, moist air from the ocean below. It's a self-reinforcing cycle that, under the right conditions, can rapidly intensify into a full-fledged hurricane. The warmer the ocean surface, the more energy is available to feed this cycle, resulting in stronger storms. But it's not just the warming oceans that are contributing to more powerful hurricanes. Climate change is also altering atmospheric patterns in ways that can exacerbate hurricane development and intensity. For instance, changes in wind patterns can affect how hurricanes move and intensify. Slower-moving storms have more time to draw energy from the warm ocean waters, potentially leading to stronger winds and heavier rainfall. Another factor is the rising sea levels caused by melting ice caps and thermal expansion of the oceans. Higher sea levels mean that storm surges, the wall of water pushed inland by a hurricane-esque winds, can reach further inland and cause more extensive flooding. This increased flooding potential adds to the destructive power of hurricanes, even if wind speeds remain constant. The impact of these more powerful hurricanes is already being felt around the world. In recent years, we've seen a string of record-breaking storms that have caused unprecedented damage. Hurricane Harvey in 2017 dumped more than 60 inches of rain on parts of Texas, causing catastrophic flooding. Hurricane Maria, which struck Puerto Rico the same year, was one of the costliest and deadliest storms in U.S. history. And in 2019, Hurricane Dorian became the strongest hurricane on record to strike the Bahamas, with sustained winds of 185 miles per hour. These extreme events are not just statistical outliers. They're part of a broader trend that scientists have been tracking for decades. Research shows that the proportion of hurricanes reaching Category 3 or higher, with winds of at least 111 miles per hour, has been increasing since the 1970s. This shift towards more intense storms is consistent with what climate models have long predicted would happen in a warming world. But it's not just the intensity of individual storms that's changing. The overall frequency of tropical cyclones globally hasn't shown a clear trend, but there's evidence that the most intense storms are becoming more common. In other words, while we might not necessarily see more hurricanes overall, the ones that do form are more likely to become major, destructive storms. The implications of this trend are profound. More powerful hurricanes pose a greater threat to coastal communities, infrastructure, and ecosystems. They can cause more extensive damage, displace more people, and require more resources for recovery and rebuilding. This increased risk is particularly concerning for vulnerable coastal areas, many of which are already grappling with the challenges of rising sea levels and more frequent flooding. Adapting to this new reality will require a multifaceted approach. Improving our ability to forecast and track hurricanes is crucial, as it allows for better preparation and evacuation planning. Strengthening building codes and infrastructure to withstand stronger winds and higher storm surges can help reduce damage. And in some cases, difficult decisions may need to be made about retreating from the most vulnerable coastal areas. But perhaps most importantly, addressing the root cause of these more powerful hurricanes. Climate change is essential. Reducing greenhouse gas emissions and transitioning to cleaner energy sources can help slow the warming of our oceans and atmosphere, potentially limiting the intensification of future hurricanes. As we continue to study and understand the complex dynamics of hurricanes in a changing climate, one thing is clear. These storms are a stark reminder of the profound ways in which human activities are altering our planet's natural systems. The science of hurricanes is not just about understanding these awe-inspiring weather phenomena. It is about recognizing our role in shaping the forces of nature and taking responsibility for the consequences of our actions. In the face of more powerful hurricanes, our response must be equally powerful. It will require innovation, cooperation, and a commitment to creating a more sustainable future. By combining scientific understanding with decisive action, we can work towards a world where the awesome power of hurricanes is tempered by our own efforts to live in harmony with our planet's climate. As we move forward, let's remember that the story of hurricanes is not just about destruction and danger. It's also a story of resilience, adaptation, and the incredible capacity of both nature and humanity to evolve in the face of changing conditions. By embracing this challenge, we have the opportunity to create stronger, more sustainable communities, and a deeper appreciation for the intricate balance of our planet's climate system.